Machine Learning Course Introduction. Hello, I am back again. Welcome to the machine learning course offered by Simply Learn. I am much more confident after completing the Python course and am more confident about my abilities. I have decided to increase my knowledge in machine learning so that I can make meaningful contributions to the development of Aura. I am glad to have you on board in this exciting new journey. I am confident that this course will be very useful to you as well. For over a decade, Simply Learn has been focusing on digital economy skills. Now, Simply Learn has become the world's #1 online bootcamp. Before getting into the details, let's take a look at the features of the program. This blended learning program is a combination of self-paced learning content and hands-on exercises with timely assistance through live virtual classrooms. The self-paced learning is enhanced with demos. The program is well-suited for IT professionals, analytics managers, business analysts, banking and finance professionals, marketing managers, supply chain network managers, beginners or recent graduates with bachelor's or master's degree. We will break down the entire discussion into 6 smaller segments or lessons. They are supervised learning, regression and applications, classification and applications, unsupervised algorithm, ensemble learning, and recommender systems. We will further break down each of these sections into bite-sized sessions that you will find easy to understand. Let me also share the program components with you. The program is composed of hands-on exercises to practice the knowledge you gained, course end project to apply the skills you acquire, and spotlight videos for concept reinforcement. Let's get started. Machine learning, what you will learn. Sheila enjoyed working with the Aura development team. While she was in the thick of things, Sheila realized that she needed a better grasp on machine learning algorithms if she were to succeed in this project. She cornered Megan, the resident ML expert, and asked her for a learning list. Megan was more than happy to oblige, so Sheila started out on her ML journey with alacrity. She decided to start with a brief introduction to ML algorithms, which included a quick world through the different types of machine learning and the Python packages used in ML. Let us join Sheila in this journey. She will dive deep into supervised learning. She will explore how to prepare data for supervised learning with an eye out to prevent overfitting and underfitting. She will also endeavor to learn the different types of regression algorithms and their applications. During this course, Sheila will try her hand at applying classification algorithms like naive Bayes, decision tree, k-nearest neighbors, and random forest, and employ the automatic feature selection in Boruta. Along with Sheila, we will analyze different unsupervised algorithms like clustering and associated algorithms, as performance enhancement is a hot topic of discussion with the Aura team. Sheila has decided to spend a significant amount of time understanding how ensemble modeling works. She will also explore how different recommendation engines work and understand the various use cases such engines could be applied to. Machine learning. Introduction. Aura's development was going full swing, in terms like polynomial regression and Cohen's kappa measure started getting bandied around in team meetings. Sheila was so overwhelmed that Megan pulled her aside and suggested that she enhanced her machine learning skills. Sheila decided to start with the basics. She would understand what machine learning, or ML, is. She would explore the different types of ML and delve deeper into the machine learning pipeline and MLOps. She also decided to find out more about the Python packages used in ML. What is machine learning? In 1959, Arthur Samuel coined the term machine learning, ML. The term refers to the ability of a machine to learn from and replicate human behavior. The main aim of ML is to allow programs to learn automatically and make computers more intelligent without any human intervention, even if there are minor variations. Although ML has existed for a long time, its adoption has accelerated in recent times. Factors that contributed to its adoption include increased data capture through smart devices, phones, and the Internet of Things, increase of computation power with edge devices, devices used by end users, better internet connectivity and bandwidths, difference between machine learning (ML), deep learning (DL), and artificial intelligence (AI). Often the three words ML, DL, and AI are used interchangeably, but there are some key differences between the three. ML refers to algorithms that learn and perform based on the data exposed to it. DL refers to layers of neural networks built with machine learning algorithms to solve complex problems. AI leverages different techniques, including ML and DL, to solve problems. Here's an example. In the picture you see on your screen, the bot and the human are playing chess. The software program powering the bot requires AI to classify data, predict moves, and make decisions. AI could make the decisions by using a multilayered neural network that uses deep learning. It may use machine learning to classify the profile of the bot's competitor, the human, as beginner, intermediate, or advanced. The classification itself is made based on the data parameters used to train this model. What are algorithms? Algorithms are nothing but a set of instructions used to solve problems. ML algorithms help predict, classify, and improve the performance of any software application. Uses of ML, among other things, the predictions by ML are used to shape policies, make weather forecast, determine traffic rules, CO2 emission, forest degradation, visibility in the sky, wildfire, heat waves, and even the size of factory chimneys. Bots, data, and ML. ML is dependent on data. The performance of the algorithm is evaluated based on the quality of the data that is input. This was a brief introduction of machine learning. In the next video, we will learn about the different types of machine learning. Types of machine learning. Machine learning is of different types, depending on whether the algorithm can self-train and predict a condition or whether it needs to identify patterns to derive outcomes. It can be divided into three main categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, as the name suggests, mimics a work environment where the algorithm uses the data developed in supervised environments to deliver an output. Here inputs and outputs are known. This could be compared to a workplace scenario where a new employee learns about specific outcomes validated by his supervisor in the presence of the supervisor. Some commonly known supervised learning methods are linear regression, logistic regression, support vector machines, decision trees, etc. Examples of supervised learning are prediction of temperature increase when year-wise temperature increase is known, prediction of crop yield when season-wise crop quality deterioration is known, classification of waste when the waste items, input, and the type of waste are known. Further supervised learning helps two actions, namely classification and regression, used for prediction or binary prediction. Unsupervised learning. In this learning, no supervisor is required to prepare data as outputs may not be known for such algorithms. The program needs to find hidden patterns and recognize their relation. Examples of unsupervised learning: identification of anomalies over geographical landscapes based on the data patterns, identification and grouping of crop rot, identification of user groups based on commonalities. Reinforcement learning. In this type, the program learns from its previous errors. If the program finds the correct solution, the interpreter rewards the algorithm. If the outcome is not up to the mark, the algorithm must reiterate until it finds a better result. This type of learning is best seen in YouTube recommendations. A user searches for a particular song, and the program shows the list of songs available. When the user selects a specific song, the system trains itself to remember and deliver a similar result for future searches. Examples of reinforcement learning: games where players can play with OTS, spell check, autocorrect tools, search recommendation engines. This was about different types of machine learning. In the next video, we will learn about machine learning pipelines, MLOps and AutoML. Machine learning pipeline, MLOps, and AutoML. Machine learning pipeline. A machine learning ML pipeline is a series of sequential steps used to codify and automate ML workflows to produce ML models. It is an end-to-end construct that includes and orchestrates data extraction, raw data input, pre-processing, features, outputs, model parameters, model training, deployment, and prediction outputs. Although the term pipeline implies a one-way flow of data, ML pipelines are cyclical and iterative. Every step in the sequence is repeated several times to continuously improve the accuracy of the model until a successful algorithm is achieved on specific outcomes validated by the supervisor. Machine learning and operations professionals, MLOps. MLOps is a set of practices that combines ML, DevOps, and data engineering to ensure reliable and efficient deployment and maintenance of ML models in production systems. It aims at improving communication and collaboration between ML and operations professionals, shortening and managing the complete development lifecycle, and ensuring the continuous delivery of high-quality predictive services. MLOps consists of 3 phases. They are design, model development, and operations. The design phase involves understanding the business and data, and then designing the ML-powered software. The next phase, the model development phase, is where the applicability of ML for the problem is verified by implementing proof of concept (POC) for the ML model. Finally, the operations phase focuses on delivering the developed ML model in production. All 3 MLOps phases are interconnected and influence one another. The tools used for MLOps are Qflow, MLflow, Data Version Control, DVC, Pachyderm, Metaflow, Kedro, Selden Core, and Flight CI or CD pipeline automation. A continuous integration CI, or continuous delivery, CD system is used to test and deploy new pipeline implementations automatically by providing a rapid and reliable update of the pipelines in production. A CI or CD pipeline automation helps in coping with dynamic changes in the data and business environment. Automated machine learning, AutoML, combines the best practices in automation and machine learning to make ML accessible to a wide range of users. It enables organizations to build and deploy ML models using predefined templates, frameworks, and processes to speed up time to completion. It also helps enhance the functionality of ML models. Some AutoML tools used to automate ML processes are Run AI, AutoKeras, H20 AutoML, SMAC, AutoEka, AutoSKLEARN, AutoPyTorch, and Robo. We have explored machine learning pipeline, MLOps, CI or CD pipeline, and AutoML in this video. In the next video, we will discuss the different Python packages used in machine learning. Introduction to Python packages for machine learning. Python is a high-level programming language that helps programmers to write clear, organized, and logical code for both small and large-scale projects. Though it was released in 1991, Python has gained immense popularity in recent times due to its ease of use, object-oriented approach, code readability owing to significant indentation, and an evolving open-source community that builds Python libraries. The advent of open-source Python packages has helped accelerate the field of data science. Earlier, machine learning (ML) tasks had to be coded manually, making them time-consuming and computationally inefficient. With the adoption of Python, a general-purpose language understandable by humans, one can easily perform complex ML tasks and build ML models without getting into the underlying algorithms. Python also helps to rapidly build and test software prototypes. Python packages are folders and modules that form the building blocks in Python-based programming. Python libraries are a collection of packages or specific files containing pre-written code, which can be seamlessly imported into a codebase using Python's import feature. Python packages from different Python libraries can be imported and used to build ML models faster. Some Python libraries used in machine learning are NumPy, Pandas, TensorFlow, Isara based on Theano, Matplotlib, SciPy, scikit-learn, Keras, and PyTorch. NumPy and Pandas help manage the preparation, loading, and manipulation of data. TensorFlow and Isara can be used for fast numerical computing. Matplotlib is used to plot data. SciPy is useful in solving mathematical equations and algorithms. Scikit-learn provides efficient versions of common algorithms that help develop ML models. Keras makes the implementation of neural networks easy. PyTorch specializes in deep learning applications and accelerates the path from prototyping to deployment. Google Colab. You can set up a coding environment on local machines, such as laptops and desktops or cloud-based solutions. For a quick start, you can use Google Colab. It is a cloud solution that enables you to run Python notebooks on your browser using the Google Cloud Platform, GCP. However, Google Colab can be used only for research and learning and not commercial purposes. In case you choose to code on your local machine, refer to the official documentation to ensure that the device specification suits the Python package requirements. We will be using Google Colab for the tutorials in this course. The image on the screen shows how to install packages in Google Colab to run ML-relevant Python packages. This video was an introduction to Python packages used in machine learning. In the next video, we will be diving into supervised learning and its application. Let's have a quick recap of the lesson. We learned that the term machine learning refers to the ability of a machine to learn from and replicate human behavior. We also learned that while machine learning refers to algorithms that learn and perform based on the data it is exposed to, deep learning refers to layers of neural networks built with machine learning algorithms to solve complex problems. Further, we discuss the different types of machine learning pipelines, machine learning and operations professionals, MLOps, and its different phases. Automated machine learning, AutoML, and the different tools used in AutoML. We also explored the different Python libraries used in machine learning. Introduction to supervised machine learning. Sheila was excited with the progress. she was making with machine learning. The team had decided to use regression algorithms to map client audiences to relevant platforms. Sheila decided to learn more about supervised learning and its applications. She will identify the appropriate way to prepare data. She will discuss overfitting and underfitting and learn how to detect and prevent them. Supervised learning. In supervised learning, machines are trained with labeled data as input. The machine learning model must identify the patterns and methods learned from them and output predictions on the data set. An operator who knows the correct predictions corrects the model if any prediction is incorrect. The process continues until the algorithm achieves the highest accuracy. Supervised machine learning algorithm techniques include linear and logistic regression, multi-class classification, decision trees, and support vector machines. Generic example that represents supervised machine learning. Industrial illustration of a model to determine whether an incident is a fire incident or not. Used in detecting forest fires, oil and gas tragedies, shipping fires, building fires, and so on. The training data to create a classification model for fire incident detection should include area spread of fire, smoke levels, temperature, rate of increase of spread, outcome labeled as fire incident or not. This kind of training data can eliminate false positives like a cooking fire or a campfire being misconstrued as a fire incident. This model would also help fire departments classify levels of fire incidents. It will then allow them to recognize and classify real-life situations and dispatch sufficient resources. There are two types of supervised learning algorithms: classification and regression. Classification algorithms segregate the data into two or more categories, given one or more inputs. A classification model will try to predict the value of one or more outcomes. Let's look at the example of a classification model. To segregate the emails into spam or ham, the model would first examine the data to find patterns and methods to determine whether an email is a ham or a spam. Regression. Regression algorithms try to establish the relationship between input and output variables. They are suitable for situations where the output variable is a real or continuous value. A regression algorithm is best used in forecasting or predicting the value of the stock market. As you have seen, supervised learning is a type of machine learning where the input data, as well as the correct output data, are provided. Let's take a look at different applications of supervised learning in the next video. Applications of supervised learning. Now that we know what supervised learning is, let's discuss the different applications of this type of machine learning. Supervised learning can optimize and automate processes across many industries. It can be used in HR operations to find the right candidates for job vacancies. It could be used in finance to segregate loans into good and bad loans. Seafarers can identify sea level trends using supervised learning. Let's examine a few specific applications of supervised learning. Quality inspection in manufacturing. Manufacturing and production engineering largely uses supervised learning to inspect quality and classify manufactured products into grades. It can also be used to detect the level of damage in products. For example, shrimps are usually graded as A, B, and C based on disease and discoloration. This grading can be automated with supervised learning. Likewise, manufacturing defects in aircraft parts are classified based on severity of dents, scratches, and other factors. This classification can also be automated with supervised learning. Forecasting for the maritime industry. Global supply chains depend on the maritime industry. Anything that impacts this industry impacts global trade. We witnessed this when the Suez Canal was blocked in 2021. Forecasting based on a combination of historic events and weather conditions is now possible with supervised learning. This helps us develop precautionary incident management. For example, a regression model developed with supervised learning can help predict the wind impact on ships. We can also predict tidal currents based on past data. Supervised learning could also help us forecast demand supply based on past consumer records and help reduce inventory losses. Fraud protection measures. Supervised learning models help us in our daily lives. Email. Clients mark mails as spam with the help of a learning model. In fact, supervised learning models can be trained to detect and prevent large-scale fraud. The model will learn from financial transactions with fraud patterns, cyber attacks on servers, and fake social media profiles. Waste management. Supervised learning could help classify waste into dry and wet waste and classify the different types of e-waste. This will help improve composting activities and optimize e-waste recycling. Learning models that classify customers based on their environmental consciousness could help climate-focused companies market. They could educate potential consumers based on their e-commerce patterns. It is evident that supervised learning models have a wide range of applications that could transform our lives. We'll discuss preparation of data in the next video. Preparing and shaping data. In this video, we will discuss how to prepare our data and ensuring the data shape. Let's start by importing the required libraries. We are using Pandas and NumPy. Let's read our data. We're using the Titanic dataset. Let's print the first 5 observations. Let's take a look at our data types. We have P-class, name, sex, age, sibling and spouse, parent and child ticket. Let's describe. In this case, the mean and median are not applicable for passenger ID. Let's see what is the mean for age. As you can see, 29 is the mean age and 80 is max age. Similarly, for fare, 32 is the mean and 512 is max. Let's check the data type. Let's use dfinfo or dtypes. This will give you both non-null counts as well as the data type. We can see what each values are here. Let's club siblings with spouse and parent with child ticket together. So let's create a variable called travel alone for people who are traveling alone. Let's create a variable now. Let's add it up. If it is greater than 0, then they are not traveling alone. However, if it is less than 0, then they are traveling alone. Now that we have created a travel alone attribute, let's drop the unnecessary data columns. As we know, we have already created a variable for sibling and spouse and parents and children. Along with another variable, name and ticket, which will not contribute to our model, let's delete them. Let's check if there are any missing values. As you can see, there are missing values in age and cabin. Let's replace them. Let's check in df1, since we have deleted cabin. Notice there are missing values in age. Let's replace them. We have replaced the missing values. There are categorical variables like sex and embarked. So let's try to add p-class, as in, we can create a dummy variable. Let's create a new data variable called df_Titanic. Drop first is dropping the first dummy values. As you can see, we have created dummy values. Let's try to pre-process the data. Let's create a scalar to standardize our data points. Let's create x and y values for the same. Now, let's import one library called pre-processing. Let's create minimum maximum scalar and standard scalar. Now, let's transpose that. Let's call it as M or min-max scalar. Now, let's transfer the data. Let's print our data. If you observe age and fair in min scalar, it has changed from 0 to 1. So some of the attributes you can see are in the range of 0 to 1. Let's check the same for standard scalar. Min scalar will be using the x values. For example, one value, x minus x minimum, divided by x max by x minimum. For standard scalar, we take the origin, minus the mean of distribution, divided by standard deviation of distribution. These are the major differences between min-max scalar and standard scalar. Now, let's check the same for standard scalar and how the data varies. As you can see, the data has negative values too, and it also has converted the dummies we created. It always depends from case to case whether you want to consider min-max scalar or standard scalar. So this is how you prepare the data, cleanse the data, and if required, pre-process the data. Overfitting and underfitting. We use terms such as overfitting and underfitting to define how well our machine learning models are learning and applying what they learned. Before we look at these terms in more detail, let's first understand what the terms bias and variance means in this context. Bias is an error introduced in the model. High bias means there's a big difference between the actual and predicted values. This is not good for our model. Low bias indicates that the difference between the actual and predicted values is low. Variance indicates how scattered our data is. High variance indicates more scattered data and low variance indicates less scattered data. Overfitting. When there is low bias and high variance in the data, it is overfit. Overfitting happens when a model focuses on too many details in the training data set to the extent that it negatively impacts the performance of the model on a new data set. For example, if you train a machine learning model that predicts climate change to consider only -2 degrees Fahrenheit as cold temperature, it is overfit. The model will not consider any other temperature as cold and will not make accurate prediction. Underfitting. When there is high bias and high variance in the data, it is said to be underfit. Underfitting is easily detectable as it will exhibit poor performance even on the training data set. For example, if a model to predict climate change is trained with limited features like temperature and wind speed, it is underfit. If the model encounters other climate conditions like rain or snow, it won't be able to detect patterns. In short, if our model performs well on training data as well as on testing data, it is said to be a good model. If our model performs well with training data, but not with testing data, it is overfit. If our model does not perform well on both training data and testing data, it is underfit. Now that we understand overfit and underfit, let's move on to detecting them. Detecting and preventing overfitting and underfitting. In this video, we'll see how to detect overfitting and underfitting problem. Let's start by importing the libraries.